Introduction. The threat of global warming and carbon emissions is omnipresent in today's society. One of the most important challenges today is finding a clean energy, sustainable alternative to fossil fuels. A solution that is becoming increasingly popular in politics and business is hydrogen, widely touted as the fuel of the future because it emits almost no greenhouse gases. Much research is currently being conducted to find the best ways to yield and store the material. Hydrogen can potentially become a vital component of a carbon-free, climate-friendly future. The production of hydrogen. A variety of home resources can be used to manufacture hydrogen. Natural gas is the primary source of hydrogen in the United States today. Hydrogen production is now being done using electricity either from the meter or from renewable sources like solar, geothermal, wind, or biomass. Hydrogen production can be fueled directly or indirectly through solar power, but sunlight is only available for a short period each day. The wind is a plentiful yet erratic source of energy. At the current moment, hydrogen is produced from natural gas through electricity, but renewable sources such as solar or wind power present some challenges. Potential benefits and opportunities of hydrogen-based fuels. Hydrogen fuel presents an opportunity to diversify power and energy sources and reduce global dependency on fossil fuels. Its benefits include the absence of contaminants or greenhouse gas emissions during use since water and heat are the only byproducts. It is still possible to considerably cut emissions by using hydrogen-based fuel cells to generate electricity from fossil fuels. These fuel cells are very reliable and flexible in installation and operation. Furthermore, hydrogen offers a political advantage since it decreases dependence on foreign oil. Hydrogen fuel is beneficial because it has no adverse effects on the environment. Storage and distribution of hydrogen. There are a variety of ways to store and distribute hydrogen. The most widely accepted way of storing it is in the form of compressed gas in high-pressure tanks or dewars at -253 degrees Celsius. Furthermore, hydrogen can become a solid either by absorption or reaction with metals and chemical compounds and transferred by ships, aircraft, and trucks over long distances. Pipelines can be employed as pressure storage systems for regions with substantial hydrogen demand. It can then be distributed through subterranean pipes from the site of production to the point of use. Hydrogen is usually stored in high-pressure tanks or dewars and distributed through pipelines. Potential industrial uses of hydrogen. Hydrogen has many industrial applications due to its chemical makeup and conductivity. Firstly, it is involved in the commercial extraction of tungsten ore. Welding refractory metals with tungsten can be accomplished by atomic hydrogen welding. Secondly, hydraulic cracking is a typical method for producing petroleum products, such as gasoline and diesel, from hydrogen. The Haber process to produce ammonia also requires hydrogen. Secondly, saturated oils and fats are made from unsaturated fats by utilizing a hydrogen-shielded arc over two tungsten electrodes. Thirdly, hydrogen is used in the production of semiconductors, displays, LEDs, photovoltaic modules, and other electronic components as an effective reducing and oxidizing agent. Hydrogen can be used in food, metallurgy, consumer electronics, oil refinement, and chemical treatment. The advantages of hydrogen technology. Hydrogen fuel cell technology has many advantages over internal combustion engines running on gasoline. While the latter emits carbon monoxide that can potentially become deadly without proper ventilation, hydrogen fuel cells do not emit any carbon dioxide during their operation or production. Using hydrogen as a power source is virtually energy neutral since the amount of energy required to manufacture it equals the amount of energy it generates. Furthermore, hydrogen fuel cells are twice as efficient as internal combustion engines and require merely 3 minutes to recharge. Hydrogen technology is highly advantageous because of its energy-neutral, low-emissions production and highly efficient, fast-filling fuel cells. The disadvantages of hydrogen technology. However, hydrogen has several disadvantages which must be acknowledged before it is hailed as the solution to the world's energy crisis. Although it is the most abundant element on the planet, it is frequently mixed with other elements and must be extracted before using it as an energy source. Since solar and wind power are unreliable sources of electricity, the standard extraction method is natural gas reforming. This is a carbon-intensive process that contradicts the concept of emissions-free energy. Furthermore, it is very expensive compared to other kinds of energy because of the intricacy of the hydrogen generation process. Another contributing factor to its expense is the high combustibility of hydrogen, which makes it difficult to store safely. Metals can become brittle and breakable if hydrogen gas is improperly stored and escapes from confinement. The drawbacks of hydrogen include its complicated extraction and combustibility, which means considerable investment is required to organize the proper infrastructure for hydrogen fuel cells. Conclusion. In conclusion, hydrogen technology is widely seen as the fuel of the future, but it still presents some challenges that remain to be solved. Hydrogen is the smallest, lightest, and most common element in the universe. Hydrogen fuel cells can significantly reduce greenhouse gas emissions since water and heat are the only byproducts during operation. They are more efficient than internal combustion engines and have a filling time of merely 3 minutes. However, mass adoption has been hindered due to the costliness of the hydrogen extraction process and the technical difficulties associated with its storage. You can find this and many other essay samples on our website studycorgi.com.